Welcome to part 2 of the properties of the derivative of a vector-valued function. The goal of this video is to verify the property involving the derivative of the cross product of two vector-valued functions. So in the previous video we briefly discussed these 6 properties, and then we actually showed the proof for property 4. For this video we're not going to prove property 5, but we are going to verify it using two different vectors. This tells us that the derivative of the cross product of vector-valued function r and u is equal to r crossed with the derivative of u plus the derivative of r crossed with u. So again, we're not going to show the proof, but we will show verification with an example in this video. So what we'll do on this screen is find the derivative of the cross product using these two vectors, and then on the next screen we'll determine the right side of this equation and make sure that they're both equal to each other. So let's start by finding r crossed with u. We'll do this by evaluating a 3 by 3 determinant where the first row will be the I, j, k vectors. The second row will be the components from the vector-valued function r. So we'll have t squared, 2t cubed, and negative t. The third row will come from the vector-valued function u. So we'll have t, t to the fourth, and 4. And we'll evaluate this by using the cofactor expansion method. Remember, this first 2 by 2 determinant will be formed by eliminating row 1 and column 1. So we'll have 2t cubed, negative t, t to the fourth, and 4. This determinant will be formed by eliminating row 1 and column 2. So we'll have t squared, negative t, t, and 4. And the last 2 by 2 determinant will be formed by eliminating row 1 and column 3. So we'll have t squared, 2t to the third, t, and t to the fourth. I'm going to go ahead and write the result in component form. So for the x component we'll have 8t to the third minus negative t to the fifth. That'll become 8t to the third plus t to the fifth. Here we'll have 4t squared minus negative t squared. That'll be 4t squared plus t squared. That'll be 5t squared, but we are subtracting it. So it'll be a negative 5t squared. Here we'll have t to the sixth minus 2t to the fourth. Now we need to determine the derivative of this cross product. So we're going to have 24t squared plus 5t to the fourth. We'll have negative 10t. Here we'll have 6t to the fifth minus 8t to the third. The derivative of the cross product, or the left side of this equation, now what we'll do is determine the right side of the equation and make sure that it's equal to what we have here in blue. So let's go ahead and take the necessary information over to the next slide and continue. Notice to evaluate the right side we are going to have to find the derivative of the vector-valued function r and u. Let's go ahead and do that now. We would have 2t, 6t squared, and negative 1. And for u prime we'd have 1, 4t to the third, and 0. Let's go ahead and find this cross product first. So again, the first row will be I, j, k. Second row will be t squared, 2t cubed, and negative t. And the third row will be from u prime, so we'll have 1, 4t to the third, and 0. Let's go ahead and evaluate this. So the first 2 by 2 determinant will be from eliminating row 1 and column 1. So we'll have 2t cubed, negative t, 4t cubed, and 0. Second 2 by 2 determinant will be formed by eliminating row 1 and column 2. So we'll have t squared, negative t, 1, 0. And then eliminate row 1, column 3. We'll have t squared, 2t cubed, 1, and 4t to the third. Let's go ahead and write this in component form. So we'll have 0 minus negative 4t to the fourth. it'll be positive 4t to the fourth. Here we'll have 0 minus negative t. It'll become positive t, but we are subtracting it, so it'll be negative t. Then here we'll have 4t to the fifth minus 2t to the third. Now let's go ahead and find r prime crossed with u. First row will be from r prime, so we'll have 2t, 6t squared, negative 1, and then u will give us t to the fourth, and 4. So eliminating row 1, column 1, we'll have 6t squared, negative 1, t to the fourth, and 4. Eliminating row 1, column 2, we'll have 2t, negative 1, t, and 4. Row 1, column 3, we'll have 2t, 6t squared, t, and t to the fourth. So in component form, we'll have 24t squared minus negative t to the fourth. That'll be 24t squared plus t to the fourth. Here we'll have 8t minus negative t, or 8t plus t. That'll be 9t, but we are subtracting it, so it'll be negative 9t. And then here we have 2t to the fifth minus 6t to the third. Okay, so what we're trying to find now is the sum of these two cross products. Let's go ahead and figure out what that would be. So we're just going to go ahead and add the corresponding components. Let's go ahead and color code them. We're going to add this with this, this with this, and this with this. So we're going to have 24t squared plus 5t to the fourth. We're going to have negative t plus negative 9t, that's negative 10t. And then combining the z components, we're going to have 6t to the fifth minus 8t to the third. So now we have found the right side of this equation to be this vector valued function. And this should be the same as what we found on the previous screen. Let's go ahead and check it. Here's the derivative of the cross of r and u. And here's the sum of r crossed with u prime and r prime crossed with u. And it's a perfect match. So it's not a proof, but we have verified that property is valid. That'll do it for this video.